Techno Tentacles is our attempt at creating a robotic tentacle arm that can respond to our commands to attack an enemy, causing havoc at the SEC. If no enemies are on site, the arms would just dance to music in peace. We wanted to achieve these controls using two major components, a voice recognition module and a low-pass filter. To convert speech to a robotic command, the speech recognition module has to go through several complex steps. Vibrations in the air from our commands action and stop are captured by the module as an analog signal and then translated into digital data using an analog to digital converter, or an ADC. An ADC filters, samples, and quantizes the sound as shown in this diagram. It first filters the incoming signal to remove unwanted noise by separating it into different bands of frequency and then takes precise measurements of the wave at frequent intervals to be quantized. It also normalizes the sound or adjusts it to a constant volume level and temporally aligns it to match the speed of the template sound stored in the system's memory, since the commands might have been set at different speeds. The signal is then divided into small segments as short as a few hundredths of a second, which are then matched to known phonemes in English before being fed into the speech recognition program. This program examines the phonemes around each other and runs a complex statistical model to compare them to a large library of known words, phrases, and sentences. Then the program outputs what it believes the individual was saying as either text or, as in our case, a command for the robot that is checked to control the servos. I trained the VR module with 3 words: action, robot, and stop. Whenever I said action into the VR module's built-in mic, the servos would start rotating into the desired configuration for attack. We experimented multiple times to get the right configuration for this, as well as the configuration we wanted when the arm was just supposed to dance. This required setting the servos to rotate at different degrees at different timings.
For our low-pass filter, we wanted to isolate just the base frequencies of different songs that we wanted to input into our filter. To do this, we created an active low-pass filter with a cutoff frequency of 250 Hz. This filter used a DC block to pass the AC current from our mobile devices connected to the circuit and blocked any DC signal that might be outputted through the headphone jack. This output was sent to the Arduino+VR3 Shield system using an analog pin. Because Arduino contains a 10-bit analog to digital converter, this signal was mapped to a voltage between 0 and 1023. Because our filter was a first-order low-pass filter, the cutoff frequency was not sharp enough to completely attenuate the frequencies above 250 Hz. To do justice to the base frequencies, we determined a proper threshold value. And because most songs have frequencies that are between high and low, we decided to create a running average filter with a window size of 3 readings to get an average waveform of the digitized signal. If the readings were above our threshold, the LED turned on, and if the readings were below the threshold, the LED turned off. The LED would turn on and off at a higher frequency when we played songs with a heavy bass, as compared to songs such as opera, which consisted mostly of higher pitches.
For our arm, we decided to go with a design similar to Dr. Ock's Tentacles in Spider-Man. Fortunately, there were already some designs for this type of arm we were able to find online. The design we chose involves 2 servos which shorten in length and 2 wires running through tentacle joints which allow the arm to twist in different directions. To assemble the arm, we 3D printed a mount for the servos as well as the joints for the arm. After everything was printed, we pinned the joints together with aluminum pins and attached springs to the pins. We then ran fishing line through the joints, attached it to the servos, and tied it off at the end of the arm. We decided to use continuous servos instead of standard servos to power the arm so that we could get a wider range of motion while keeping the servos close together in the servo mount.